Okay, so ladies and gentlemen, today, just a reminder, your final is in here on Wednesday, 7:30 in the morning. Be on time. If you want to use your computer, make sure you bring it charged. Your periodic tables, your cheat sheets, all that stuff you got to bring with you. Okay? So again, anything that you're using on these practice tests, bring with you for that regular test. You are here till 9, so use the bathroom before you come into class that day. The only way you leave the class is if I can get a monitor to come up and escort you. And you should be able to handle it because I can't leave the class either. So, questions on any of that? All right. So, what group am I? I show sp3 hybridization with a linear geometry. What group shows an sp3 hybridization with a linear geometry? There are two groups that show linear geometry. What? Group 17. Group 17 shows sp3 hybridization because there are 4 total pairs of electrons. 3 are unbonding, or 3 are lone, 1 are bonding. That is a linear geometry. I show sp3 hybridization in a tetrahedral geometry. Okay, slow down. Let everybody have a chance to look around. All right. Group 14, the carbon family, ladies and gentlemen. They show sp3 hybridization because they use 4 total pairs of electrons. The difference here is that all of them are bonding. All 4 pairs are bonding pairs, no lone pairs. So they have a tetrahedral shape. I have electrons in every p orientation, but 2 are only half filled. So there are some electrons in every orientation, but there are 2 of them that are half filled. What group? How many p orientations are there? How many p orientations are there, Natalie? Orientations of a p orbital. Nope, not 4. Oh, wrong way. Claire, help her out. 3. There are 3. There are 6 total p electrons. So therefore the orientations are half of the total electrons. So since there are 6 total p electrons, half of that would be 3 orientations. 1 of them has to be filled, 2 of them have to be half filled. How many electrons is that in the p? Jesus? 4. What family on the periodic table has an electron configuration that ends p4? Hold on. On your periodic table, which one ends p4? Which one? Oxygen or group 16? Absolutely. Thank you very much. Questions? All right, now I saved the hardest one for last. I have ionization energies of 120 kilojoules, 245 kilojoules, 350 kilojoules, 780 kilojoules, 900 kilojoules, and 1035 kilojoules. From that information, you can tell me what group I am talking about. But what you have to look at is which one seems out of place. So when you look at those numbers, ladies and gentlemen, which one seems out of place compared to the others, and why? Anyone? And looking at those numbers, there's one that is quite a bit different than the others. Nope, not the 1,000 one. No, no. That one just randomly did, sorry. But that is a good guess. It's the only one that is even. 1,000 also, it's the only one that's really, really high, right? Why? Okay, it's the only one that like is a whole number. Nope. Well, we're getting down there now. Only a few left. Take a chance. We're still happening. You'll be wrong. Ethan.
780 because it goes in a pattern of like ending in 0, then ending in 5, and then 780 because of the bottom.
Okay, you got the right number, but that isn't the right reason. But you're right about the reason. You're right about. Let me rephrase it. You're right. 050005 just happened to be that way. But 780 is the one that is different compared to the others. Here's why. 120, you double it, what do you get? So this is almost doubling, right? You add another 120 to this, you get what? Okay, math. What? 365. This is close to that, right? Add another 120, what do you get? All of a sudden we're at 780. Then add about another 120 to this. What do you get? Add another 120. So this one is the one that took a lot of energy. Why did this one take a lot of energy? No, because the noble gas would have been the first one, right? Taking away the first one. Thank you. Which one is the 780? Which ionization energy is it? Count them. Which one is it? First ionization energy, second ionization. 780 is the which ionization energy? The fourth. And it is the highest. Highest fourth ionization energy, ladies and gentlemen. Group 13. Group 13. So, suddenly it took a lot of energy to remove an electron. Now, you were right about the idea behind it, Jesus. When you're a noble gas, you don't want to lose an electron. But this one, after it lost 3 electrons, it was okay. It had a hard time losing the 4th. That's group 13 on your periodic table. Guarantee you there will be a question like this on your test. Guarantee. Questions? Okay, you've got the hour to get periodic table practice test number 2 done, ladies and gentlemen. The answer key is up here if you want to come and check it. The video is online for how to get all the answers. Here's the one from practice table 1. Here's the one from practice table 2. And if you get done, ladies and gentlemen, here's the one for practice table 3. So, you should have something to work on, something to keep you busy. If you lost one of these sheets and you need a new one, they are up here for you as well. If you need any of the other things, they are up here as well. You can come up and grab them. I would suggest get with a partner, work on those, work on them alone, your decision, but let's get some work done. Go.